This lesson isn't recorded live because I needed to be able to show you both Desmos and the notes, so bear with me. It's going to go a little bit faster than normal because it's not a live video. So scatter plots, which we highlight since that's one of our words, is something we've learned about before. You would have heard about it in 6th, 7th, or 8th grade. Scatter plots are discrete or disconnected graphs that show a relationship between two data sets. So we always are going to have something on our x-axis and something labeled on our y-axis to show the relationship between them. There's three types of relationships that we can have when we are working with scatter plots. The first one, since as the x's are increasing, the y's are increasing, this is called a positive correlation, just like it would have a positive slope if I drew the trend line in between it. Positive correlation, like a positive slope. Since as the x's increase, the y's are decreasing on this one, we have what's called a negative correlation. As I have more of whatever we're measuring on the x-axis, I'm going to have less of whatever we're measuring on the y. And then since this one's just kind of all over the place, there's no real trend line that I can draw. It would be kind of flat. This is called no correlation. Usually we're going to be able to find one of the two positive or negative correlations between data sets. And in high school, what we're working on is more specifically describing these data sets in multiple ways, 3 ways. We're going to talk about the line of best fit, a correlation coefficient, and causation versus association. There are 3 more detailed ways to talk about these scatter plots and the correlation between them. Now, line of best fit is the bulk of the lesson today. When I'm asking you for a line of best fit, I'm asking you to find the equation of the trend line. So the equation in y equals mx plus b format, where I need a slope and a y-intercept, that best models the data or best represents the data. Okay, so now that trend line that we drew through it to decide if it's positive, negative, or no correlation, we have to get very specific on what the equation is for that data. There are 5 very easy steps to do this, and we are going to solve this electronically with technology. You don't really do it by hand until you're in college, so we're going to hang on and not do it by hand. We're going to use our technology to help us. So I'm going to walk through the steps for everything and then show you an example. The second half of your notes, by the way, let me zoom over here for a second. Oh, sorry, it's down here. The second half of your notes, the other page you picked up, is the steps for doing this in Desmos, but with pictures, so that when you're reading it, you can remember what I mean by add a table. That means press the add item button and then a table. So that's there for you. We're not really talking about these notes at all. It's these steps in pictures, just so you can have it to help you if you need it. Okay, so the first step is to add a table in Desmos, and then you're going to fill in the table with all of your data points. Every single one that's either in your scatter plot or in your XY table, you're going to plug into the table that Desmos has created for you. Now you have to make sure that you put all of the X's in the column that's titled X1 and all of the Y's in the table titled X or Y1. Okay. Just like last year, if you've done stat edit, this is going to sound familiar to you. That's what you're doing is stat edit, but on Desmos, it makes the statistics a little bit easier to see. After you've typed in all of your data points, you're going to click the, and don't laugh at my artistry, this is a magnifying glass, so that the data will be fit to your screen. It's going to auto zoom your screen so that you can see all of the data points that you have entered on Desmos. You are then going to type this following equation, which is an annotated, funky version of y equals mx plus b. It's y1, squiggly line, tilde, or approximately, mx1 plus b. So it's almost y equals mx plus b, but it's just a little bit different. Now, if you're looking at a keyboard, that squiggly line is found on a button at the top of your keyboard, pretty much underneath the escape and up above the tab. But if we want the top symbol, the squiggly line, we're going to have to press shift and that button, and it will create the squiggly line. Then we're going to use the M and the B that has been generated from the programming on Desmos that you have programmed into the computer to write our line of best fit back in y equals mx plus b format. Now, Desmos is most likely going to give you the M and the B in decimal form, and that's fine. The only problem is if your answer choices for me or on the star are in fraction form, All you'll have to do is match up the fraction to decimal, either changing the answer choices to decimals to match what you have on your screen, or changing your decimals that you have to a fraction to match it up on the test. Okay, that's writing the equation of the trend line, or the line of best fit, the line that comes the closest to touching all of the points and representing your data. Now, the next measure of data we have to talk about is what's called the correlation coefficient. Say that to yourself underneath your breath right now. Correlation coefficient. It is also called the R value. So when I ask you what letter we're looking for with correlation coefficient, you're going to tell me the R. Okay, it stands for residuals, if that matters to you, but it's the correlation coefficient. It is the measure of the strength and the direction of the line of best fit. Okay, because we can find a correlation between any data points, but we have to know, as people who consume data, as someone who would maybe read the news and see some data and they're going to present it to you, how good that data is. If it's strong, it's good data. If it's weak, it's not as good of data. Let me explain why. Okay, when you're talking about a correlation coefficient, you have to give it two adjectives. The first adjective is really easy. If when you calculate your R value, you get a negative number, it's a negative R value. That means my trend line is going down, like these two examples. But depending on what number is given to you, it's going to be anywhere from -1 to 1. And on this scale, you have to decide if it's strong or weak. The way I like to think about it is if the number you get would round to -1, 5 or more raise the score, 4 or less let it rest, you're going to call it a strong negative correlation. If your number would round more closely to 0, like maybe it's like -0.2, that's closer to 0 than -0.9 is, you would call that one a weak negative correlation. What happens there is the data points aren't as close to the line as they would be if it was a higher correlation coefficient. So there's still a trend, but it's not as directly related. Similarly, on the positive scale, if the number you get is any positive number, it is definitely going to have the adjective of positive. But just like with negative, if it is pretty spread out here on the graph, you're going to call it weak. Or if that number is small, like 0.35, that's a weak positive correlation. But if it's super strong, like 8.9, that rounds closest to 1. So we're going to call that a strong positive correlation. The data points would be really, really close to the trend line that you created, making it a strong correlation. Okay. Correlation coefficient, again, tells you the strength and direction, strong or weak, positive or negative, for the correlation or R value that you find. The last thing that we're going to be talking about with data is called causation versus association. Everything we do is for sure an association. Some of the data points that we look at, though, are specifically called a causation. Now, if I misspell causation / like just cut out the rest of the word, do you see the word cause? What normally comes after cause? And effect. My friends, causation is just a cause and effect relationship between the x variable and the y variable. A relationship or an association where the y or x variable causes the y variable to change. Causes causation. Okay? Because we can make data and make an association between literally anything. You have to be smart enough to say, these are not actually cause and effect. This one is just data points put together. So for example, a causal relationship or causation could be the amount of homework that you turned in and your overall grade. Because the more homework you turn in will directly affect your grade. Hint, hint, wink, wink. Okay? But an example of an association might be the temperature outside versus how long my hair is. Does the temperature outside have anything to do with how long my hair is? No. I can still make a scatter plot for this, but it's not going to make any sense for that data to be related together because it does not show causation. This is how people try to trick you. Okay? For example, let's say I have this data and I legitimately got this data off the internet, okay? This data came from the internet and it has a correlation of 0.99. that's super close to 1. So you'd say this is a strong positive correlation. Oops, did not mean to write. This is a strong positive. But look at what we're actually measuring here. We're measuring the divorce rate in Maine versus the per capita consumption of margarine. That's butter. Does the amount of people who are divorced in Maine change how much butter we eat? No. But you know what? Someone who is trying to trick you might tell you how high this correlation is because the data is really close together, but you have to be smart enough to say, yeah, but that's not causation. Divorce rate doesn't cause us to eat butter. Or, for example, this data set that I got off the internet has a strong positive correlation. Okay, these data points are really close together, but it's representing the number of people who died by becoming tangled in their bed sheets versus the money made at a ski resort. Do these have anything to do with each other? No, this is just a regular association that does not show causation because these two things have no cause and effect relationship. You have to be smart enough as a consumer to say, oh wait, even though this is super strong, this data doesn't make sense for it to be a causation. But let's say they show you this. Number of homework assignments turned in versus your grade on the DCP. We have a strong positive correlation because my R value is a strong positive number. Okay, our trend line goes up, which means more number of homework assignments you do, the higher your grade is probably going to be. Okay, this is legitimate data from my classes last year, just so you know this. But does this show causation? Is the number of homework assignments you've practiced and turned in directly affect how good you're going to do on a test? Yeah. The more you've practiced, the more prepared you are for the test. So when we're using data points, I can answer all the questions that are going to come up on a test regarding the line of best fit, the correlation coefficient, all of that. But at the very end of the day, I have to be able to say, is this causation? Does the X value actually affect the Y value? And sometimes it's no. Sometimes it's yes. You got to be smart enough to tell me whether it's yes or no. Okay. That's the end of the information for today. We have to go to some example problems because it's not going to make sense till you see an example. So we go to the inside of the notes here. We're actually going to start on question number 2. It says the table shows the number of teachers and the number of students in each of several schools. Cool. Here's our data table. So that means at a school with 10 teachers, you're going to have 250 students. Okay. On and on. Part A says we highlight, find the line that best models this data. Guys, that is asking me for the y equals mx plus b that represents this table. So we go to our line of best fit, or y equals mx plus b steps. Now I'm going to have to show you on Desmos, which means I can't look at the see the screen, but follow along with me. Okay. In Desmos, we're going to click add, and then we're going to choose table because we want to add a table to our graph. We're going to type in all, not just a few, all of the data points from the table that was given in the problem. Every single one of them, making sure I don't have any typos because a single typo will mess up your answers. And once we have all the data in there, I want to press zoom fit because if you notice, nothing showed up on my screen over here. Okay. But if I press zoom fit, it has shown me the data points that I've typed in. This is 10,250, 12,275, and on and on. These are the data points that I've put in to my table. Now, it says next in the steps to type the funky equation, which is y1, and literally to do that, I just press y and then press the 1. It creates the subscript. I press shift and the funky little button, the squiggly line, mx1, again, just press the 1 right after, plus b. And the moment I do plus b, all of this information shows up over here. This is what I want because it has shown me the m and the b that create this line for me, this line of best fit. Okay, we come back to our notes here and we're going to answer the question. Now it does say to round your slope to the nearest tenth, which is 1 decimal. And it says to round your y-intercept to the nearest integer, which is a whole number. Okay, we can still see over here, so clicking back and forth is not necessary. But if I want to round the m to the nearest tenth and keep 1 decimal, I look at the second decimal and say, 5 or more, raise the score. 4 or less, let it rest. So I'm going to let this one rest at 20.6. That's my M. And then my B, I need to round to a whole number, just because it's asking me for that. So 42 is where I want to stop. So I look at the first decimal, I say 5 or more, raise the score. 4 or less, let it rest. So that's going to rest at 42. That right there, my friends, is the line of best fit for this data. Woohoo! We've taken the M and the B generated from Desmos when you programmed it, putting all this data in, and we've created a slope and a y-intercept. Now, most of the time with these questions is going to have you predict the future, make a prediction. So we're going to take this data and make a prediction for the number of students in a school where there are 26 teachers. Now, if they gave me teachers, did they give me an X term or a Y term? They gave me an X term, it's my X column. So that means X is 26 and I want to know what Y is. Well, you have now created an equation right here. Y equals 26, or sorry, X equals 26 is an equation I can type into Desmos. It should be a vertical line because it's a Vux line. And nothing showed up, so I'm going to zoom out a little bit. Oh, there's the line that represents 26. And so when X is 26, what's Y? 579. Again, I just clicked this little point to see the input and output that's matched up with 26. So I would say that the output is 579 students. That's how many students I can predict would be in a school that has 26 teachers. Now, these are very small schools. We have about 250 teachers and about 3,000 students. Okay. Now, part C asks me, what does the correlation coefficient, we highlight, for the data indicate about the strength of the linear association for this data? Then we're going to round this to the nearest thousandth. Now, if I look on my Desmos, we're looking for the R value for correlation coefficient. And my R value is 0.9595. But I want to round it to the nearest thousandths, which is 3 decimals. So I keep 3, 1, 2, 3, and I look at the next one. I say 5 or more, raise the score. 4 or less, let it rest. That's a 5 or more, so I'm going to raise the score, which means the 9 becomes a 10, which means the 5 becomes a 6. And I keep the 0 because I want 1,000. Now, we give it 2 adjectives. Is this a strong, weak, positive, or negative? Well, it's super easy to do the positive part because it's a positive number. It's not a negative R value, so we're going to say positive. And then would that number round closest to 1 or to 0? Well, it's 5 or more, so you raise the score. This is strong. Okay, on that number line that we have over here, 0.9 would be approximately right here. That's a strong positive correlation. So we know that this data is pretty accurate. We can be pretty confident in our prediction here because we have a strong correlation. Now, does this data show causation? Is it a causal relationship? These are a little difficult. The easiest answer is correct. Does this data show causation? Does the number of teachers I have in a school affect the number of students I can serve? Yes. If I have more teachers, I can serve more students. That's something I know about the way teachers and students work together. If I have more teachers available at a school, the school can handle more kids, more students. So it's a cause and effect relationship. Now, I have some people be able to say, no, not really, Ms. Quigley, the number of students affects how many teachers there are. True. The easiest answer is the answer. Don't get into the what ifs or what about. The first thing you think is usually correct. On questions that are going to ask about causation and association, there is an obvious correct answer. They're not going to give you some that you could make work in your head. You're going to have one that for sure works in your head the best. Okay, so don't get into the what ifs on the causation and association. That's the whole shebang. So all of the data and information to answer all these questions does come from this Desmos programming. You can do this on a graphing calculator. It's just not as cute. It doesn't visually show you what's going on, and we're all visual people. So we're going to continue to use Desmos also because it's free and you can use it at home because it's a website and an app. We're going to continue to use this. Now we're only going to do one more example on the notes today, and it's this one, number 4. It says the graph shows the relationship between the number of donuts consumed before a math test and the student's grade on that math test measured in percentage. So this person got 100, this person got a 70, 60, 50, on and on. We want to find the line that best models the data, and we're still going to round the slope to the nearest tenth and the y-intercept to the nearest integer. So we have to repeat all of the steps that we've done in Desmos with this information. However, they didn't give me just a table, they gave me a graph. Guys, we can still make the x and y coordinates for all of these points so that we can have x's and y's as we go on. This is over 2 up 5. That's the coordinate, not the slope, the coordinate of that point. So if I find all of the coordinates, a little plotting points practice, I'm going to be able to have x's and y's to put in my table. Okay? Now, you have to make sure these line up. Doesn't matter the order you put them in, as long as 0 is always with 10, 1's always with 7, 3's with 6, 2's with 5. So you can go in number order, or you can go out of order. Does not matter. But you need to make sure that the coordinates are lined up in your table. Okay, so I'm going to show you here on Desmos, we delete everything out, and we need to add a table. And I'm going to put all of the x values in, and then I'm going to go back and put its corresponding y values in. 0 is with 10, 1 with 7, 3 with 6, 2 with 5, 4, 3, 5, 2, 6, 0. And I double check that I'm correct because I don't want to type anything in wrong. And then the data has shown up down here, but it doesn't look right because we have such a large scale on our y-intercept, which is why we want to press Zoom Fit. That looks much better. This is Fit the Data. Now I press y1, squiggly line, mx1. Nope, that's not right. 1 plus b. And the moment I press plus b, I'm literally done with my work because all the information is here. It says based on this data, make a, first question. We got to write the line of best fit, the mx plus b. Well, the m rounded to the nearest tenth. So I'm looking right here, rounded to the nearest tenth. This, look at the 3, 5 or more raised to score. Nope. So I'm going to let this rest at negative 1.5x. This is rounded to the nearest whole number. So I look at the first decimal, 5 or more raised to score. Nope. I'm going to let it rest. That, my friends, is the line of best fit for this data. Now, caveat, it's not always going to be nearest integer in tenth. In fact, a lot of times it doesn't specify how to round it, but on your homework, it's going to round this way, so that's how we're having us practice. On a test, they might just keep 3 or 4 decimals. Just look at your answer choices and keep that many decimals. Now, based on this data, we want to make a prediction for the future for the test score of a student who consumes 7 donuts. Donuts is on my x-axis, so I'm going to say that x is 7. We want to know what the output is when we have 7 donuts before this test. Well, this is a Vux equation I can type into Desmos. And when I type it in, it does give me a line. So I'm looking for where the 2 lines meet, which is the solution here. The input is 7. The output where they match is negative 1.429. So I would say that the number of, the grade that they're going to get is negative 1.429 or negative 14%. Hopefully your alarm bells are going off because we have a second question here that says, is this reasonable? Is it reasonable to get a negative 14 on a test? No, this is not reasonable. So sometimes your data, though you can measure it and create a trend line, needs boundaries. We know that this boundary would have a range, the y values that ended at 0. So we would know that this is unreasonable. We would pretty much just say it has to end at 0 because you can't make any less than a 0 based on the trend line, but we can still answer their question and then say, but that's not reasonable. Can't make a negative grade on a test unless your teacher is crazy, which I am not. Letter C says, what does the correlation coefficient, what letter is correlation coefficient? R. What for the data indicate about the strength of the linear association, round it to the nearest thousands, which is 3 decimals. So if I look at my R value back on my screen from Desmos, not R squared, R value, that's something, R squared is something you'll use in college, not right now. The R value here is negative 0.98, and then I look and it's 5 or more, raise the score, 4 or less, let it rest. So I actually need to raise this one up to 10, which means this should actually be 90. Now, This is a number that's negative, so I know for sure one of its adjectives is going to be negative because it's a negative number. But then is this number closer to 0 or closer to -1? Hopefully you said -1. If I found -9 on this number line, it would be over here in the strong category. So we're going to call this a strong negative correlation. Last question though, think about it realistically. Does this show causation or cause and effect? Does the number of donuts we eat before a test mean we're going to do better or worse on this test? Easiest answer works. No, donuts don't affect grades. Now some of you are saying, but Miss Quigley, if that's breakfast, eat a hearty breakfast, or what if it gives you sugar power? Yeah, okay, you could make a bunch of what ifs to confuse yourself. But really, do donuts affect grades? No. The easiest answer is always the answer. Don't go get into the what ifs, okay? The what ifs are going to confuse you. That's it, my friends. Those are the types of questions we're going to be asked when we're using data and scatter plots to be very specific about the line of best fit, about predictions for the future, about its strength and direction, and about whether there's actually causation happening here. These are the things you're going to need to know how to answer for me in regards to data. Now don't forget, I have put all of these steps for Desmos in picture form on your second set of notes, as well as an example problem on how to get where to get the parameters, the M, B, and R, and how to decide if it's weak or strong. And then also, if you need help rounding, here's the place value chart in case they change up somewhere where you need to round to not the tenths, the integers, or the thousandths.